Okay, we've got a little bit of a prototype together here for the Physarum simulation. There's a number of things going on. Building this real quick. Okay, so basically what we're dealing with right now is a very limited number of agents, and we're seeing their pheromone trails, and there's no logic to change the direction. So basically, they're just continuing on, forever, depositing these pheromone trails. And so far as I can tell, I'm having a rough time getting any kind of scale here. It's really very strange. The way that you reference it here, even with a scale factor like this, well, okay, that's not enough information. So the agent deposits here with this image atomic add, and so at this position in the image, I'm depositing 1 unit. So in theory, that's supposed to increment that that 16-bit unsigned integer in the red channel. Though I may have just answered my own question. I think it may have to do with the fact that that's not specifically referencing the red channel. But here, I'll figure that part out. Now, this part's, kind of cool and everything, but I think I may want to do that atomic add in the fragment shader, and also I definitely need a smaller step size. Let me just real quick run this with different well, more agents, I guess, and find a resolution on what we're doing. Make it again. But yeah, so starting to home in on something here. I think, well, okay, yeah. This is doubling the size of the texture, so you're gonna have some aliasing here. This is 2048 by 2048, and that's just spanning the whole image, so it's not got uniform scaling on it. But as far as the simulation is concerned, it really doesn't matter. You can't use samplers, or what was I saying? With unsigned integer textures, you can't use nearest sampling, or no, you have to use nearest sampling. You can't use any sort of interpolation like linear or whatever. So I need to figure out how to treat this as grayscale, or rather that not have it just fully apply the red channel here. But once I finish that part, the simulation logic is not crazy. You're basically just reading from that pheromone buffer, which is the red there, that has the trails. You're reading from that the pheromone concentrations, and then you're steering the individual agents um, by by some logic that I found. It's not crazy complicated actually. It's kind of a neat thing that I found. It's around on the internet. This guy's an artist. He's done some really cool stuff, but yeah. So just as a demo of what he's done with it, the logic is sort of based on this idea of, okay, this agent here with this location pointing in this direction is going to sample the texture at these 3 points, going to make some sort of determination on how to turn, do that, make a deposit in the pheromone buffer. Then this is done with a compute shader, this diffuse and decay step. So there's actually two buffers in my implementation, which I'm using very similar to how I did a lot of the operations in Veraldo. Basically read from previous, write to current, and then each update we swap the roles of those two those two image buffers. Those are they swap each basically iteration, but that happens every frame. So it's actually quite frequent that those are swapping roles, and basically the way that I haven't gotten that 100% laid out yet, but then I think first is going to be figuring out this behavior, because when I've got this very small factor, yeah, this is just a weird one. It's see, because what I would expect is, and well, here, let me do it with some more agents. The that buffer saturates really quickly. So this is 1/10,000th. Well, I just don't think it would saturate as quickly as that. And I'm not seeing any shades of red either. So that's kind of a bit of a red flag, if you, no pun intended, that it's either 0 or 1 here. But progress anyway. And then there's going to be parameters to set and send as uniform variables here. So there's at least signs of life here. We've got at least a lot of the high level stuff figured out, and it's just down to some implementation details now. So yeah, that's where we're at on that one.